So at the end of class last time, we ran out of time and we were just starting to talk about how to find the domain of a composition function or a composite function. So let's just recap that really fast. If you want to find the domain of f of g of x, the first thing you have to do is you have to find your final answer. Then you find the restrictions for both the final answer and the original inside function. Take all of those restrictions together and use those to find your domain. So let's look at an example. If f of x is the square root of x and g of x is x minus 3, we would like to find the domain of f of g. So let's talk a little bit about that. That really means find f of g of x's domain. So we can see that g of x is my inner function and f of x is my outer function. So first thing I'm going to do is just go ahead and find f of g. So f is the square root of x. So if I remove the variable from that, and inside there I put x minus 3 instead. This is f of g of x. That can't be cleaned up, so f of g of x equals x minus square root of x minus 3. Now, we want to find the domain, so we have to consider a couple of things. First, we have to find the restrictions on that final answer. So if I look at that, this requires that what's under the radicand be greater than or equal to 0, and that x then is x is greater than or equal to positive 3. So these are the restrictions given just by your final answer. Those are your final answer restrictions. But you also have to consider the inside function restrictions. If you look back up here at g of x, we can see that the inner function, x minus 3, has no restrictions. So the inner function is x minus 3, and there are no extra restrictions given by that. But you do have to make sure and consider that. Now the outside function, interestingly enough, the square root of x, he has restrictions. X has to be greater than or equal to 0, but they don't matter. The only thing that matters in a composite function's domain is the domain of the final and the domain of the inner. So the only restrictions I have are that x has to be greater than or equal to 3. Therefore, the domain is everything starting at 3 and moving to positive infinity. Let's take a look at the other way. What if we had found g of f? Would the domain be any different? Well, first we have to remember that g of f is the same as g of f of x. Now my outside function is x minus 3. So that's going to kind of become my template. And rather than x minus 3, I'm going to put square root of x minus 3 because my inside function is f of x and it gets substituted in the place of x into my outer function. That gives me a final answer of square root of x minus 3. So if this is my final answer, that is g of f of x, I need to talk about the domain of that. Well, it's restricted. X has to be greater than or equal to 0. So those are your final answer restrictions. But you also have to consider the original inside restrictions. So here's the original inside. It turns out it has the same restrictions as my final. So the only restrictions for this function state that x has to be greater than or equal to 0. So that gives the domain for g of f of x as bracket 0 to infinity. So you can see that they have different domains. There's no way to predict it by just looking at the original problems. You have to look at the final answer, you have to work it out, you have to consider the restrictions on both the final and the original inner function. Maybe we should do another. Let's look, and this is a little more complicated, so you want to really pay attention here and you want to make some really good notes. If our original function is f of x equals x plus 3 over x minus 2, and g of x equals 1 over x, I would like to find f of g of x and find the domain of that. So That means we're looking for f of g of x. So my outside function is f of x, but I'm going to remove the x's, and in their spot, I'm going to put whatever's in the parentheses, which happens to be, in this case, a 1 over x. So I'm going to put 1 over x in the spot of both of these x's here. 1 over x, 1 over x. And that creates a situation that we've never really seen very often yet, but we will deal more and more with it as we move along. It's called a complex fraction. And to simplify a complex fraction, you simply multiply top and bottom by the least common denominator of all of the terms. So that means I have to multiply all four, 1 over x plus 3 and 1 over x minus 2 by the common denominator of those four things. And it turns out just to be x. So I'm going to multiply top and bottom by x. Now what that really means is I have to distribute. I have the 1 over x times x and the 3 times x. If you need to see it a little bit better, maybe it will help if you rewrite it this way. And you actually write the x out beside each term. Maybe that would help you kind of see the distribution a little better. I'm not sure. Have to kind of practice and see what works for you. So in this case, the x times 1 over x simply reduces to 1. 3 times x stays positive 3x. And the denominator becomes x times 1 over x, which is 1, minus 2x. So it's just kind of up to you. Maybe you can see it by just looking at it and distributing. Maybe you need to write the x by all four of your terms and look at it. There's your final answer. That is f of g of x. Now let's talk about the restriction on that. The restriction of your final answer is that 1 minus 2x cannot equal 0. So negative 2x cannot equal negative 1. So that means x cannot equal positive 1/2. So there's the restriction for your final answer. But now we have to also talk about the original inner. So the inner restriction from the original problem. The inner restriction up here, the inside was g of x. That was 1 over x. And that just means that x cannot be 0. So this guy actually has two restrictions. X cannot be 1/2 and x cannot be 0. So I can let it be any other number in the world. So if we think about it on a number line, every x is good except for 0 and positive 1/2. So we'll put that about right here. Can't be 0, can't be 1/2, but can be everything else. Can be all of these, and all of these. So we have to break that into 3 different intervals to list the domain. From negative infinity to 0, from 0 to 1/2, and from 1/2 to positive infinity. So that's a lot of work just to get that domain. But if you can understand that one, you can pretty much understand any of them. And that wraps up section 3.6.